Welcome to today's webinar. Big Switch unveils SDN-based network telemetry for deeper visibility and pervasive security. My name is Sharon Fitzpatrick, and I'll be your host for today's webinar. Joining me from our Big Switch team are Bill Erdman, Director of Product Marketing, and Praful Badazna, Director of Product Management. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video in a rebroadcast or a recording, or if you have questions on an upcoming webinar topic or anything that we've discussed today, please email us at info@bigswitch.com. We have also provided you with handouts for today's session. You can download them from the Handouts tab on your dashboard. We have a full agenda for today, so let's get started. It's my pleasure to introduce Bill Erdman, Director of Product Marketing.
Great, thank you, Sharon. And first I want to set the stage in terms of what we're going to discuss today. And primarily what we're going to provide is an announcement on several new products that we've added to our Big Mon Fabric offering, specifically an analytics and recording capability. But I want to set the stage in terms of why this is such an important announcement. They really fall in line with the need today for better monitoring capabilities, primarily from a data center focus. And monitoring has become important, as we all know, because of the security issues customers face, and equally important, the compliance, auditing, and forensics they need as well. And that is for, basically to try to find any security threats or risks that are taking place, but also for privacy, data concerns, and to be able to go back and do forensics work if there is some sort of data sharing issue. So what customers are now realizing is that they need a dedicated out-of-band monitoring fabric to handle these requirements. They're almost as important as the data itself in terms of the data plane network that you would use to get the data from one place to another. You need to have a network that you can monitor to keep track of your security threats and of course, address all these compliance and auditing issues. So you need to build a fabric, monitoring fabric that's cost effective, but as well can scale. And the challenge today is, if you look at the data center networks and that they're multi-terabit, whether they're 10, 40, 100, and moving to 400 gigabits per second, you've got to have a monitoring network that can keep up, filter out the good traffic, and get to the data that you need to basically perform your job from a security or audit perspective. And that's what we're really going to be going through today in terms of the monitoring fabric, how Big Switch Networks approaches it, and certainly the products and the tools we have there to give you effective management of your data. So for a lot of people, it's a well-known subject now with regards to building a monitoring fabric. They're typically called network packet brokers. Big Switch has taken a different approach to building a network packet broker network than some of the products out there today. Our approach has been to leverage a software-defined technology using a centralized controller and a centralized management point. And in our view, we believe that it gives you a better operational model and actually a much better sharing model. So security teams, network operation teams, forensics, compliance teams, they all need to have monitoring data to perform their job. You don't want to build 4 different packet broker networks. You want to have one central management point in which you can provide access control into it, and then have them be able to go in and control, steer, filter the data to whatever their monitoring needs are. That really requires a centralized management point, and that's what you get when you deploy a Big Mon fabric. So continuing along that vein, for those that aren't familiar with Big Switch Networks, we are really a software-defined networking company. Our core design and development principles are around a software-defined architect, and that architect is to basically disaggregate the control plane and the management plane from the data plane. And what that means is that we're moving the intelligent components and the control components up to something that is more manageable and controllable by the user community, either with a set of APIs or with a set of GUIs, and then to disaggregate the data plane into what we call a commodity-based set of switches where you see all the speeds and feeds. And that today is being well addressed with merchant silicon and a lot of switching products, if you will, that are coming out from Dell and HP and others. So it basically gives you a cost benefit, and it actually, more importantly, gives you a management and control benefit. It lowers your CapEx, it lowers your OpEx, and it gives you more programmability and automation. And that's essentially what Big Switch Networks is and what we've defined as our Big Mon Fabric offering. And just to give you an evolution of where we've been as a company, we actually started down the path of software-defined networking as it came out of the university community. We saw it as a benefit both from a virtual networking technology as well as now as a technology that you can use and deploy within your physical networks. We basically have put our technology out into the open source community for developing an open networking operating system that can run on these merchant silicon boxes that are, primarily Broadcom based. We support the latest speeds and feeds within the data center networking community, and we've created several different solutions with our technology. One is a Big Monitoring Fabric offering, another is a data center switching offering. And off of that, we're building product line extensions, which we're going to be talking to today for doing, at line rate analytics, if you will, as well as line rate recording, and Praful will be going through those. Okay, and then what's also unique about Big Switch is that we didn't define the company as a data switching data plane company, nor did we define the company as a monitoring company. So we're not a Gigamon and we're not a Cisco. We actually believe that the technologies can cut both ways, in that the fabric, if you will, whether it's a data plane or a monitoring plane, as I mentioned, they have to be multi-terabits today to keep up with the endpoints, whether it's storage or servers or a big WAN pipe. And the monitoring fabric has to keep up, as well as the data plane fabric needs to keep up. The way you keep up with that is to basically buy merchant switching, and that comes out of the Broadcom chip technologies primarily. And then you build your software solutions on top of it, and we offer two different form factors for that, with two different software releases, if you will, and that really ties into our controller technology. So from there, you can build a monitoring fabric using the same switching, or you can build a data plane switching fabric using the same switching, and it's just a different way that you control the data. And that is sort of our approach to the market, and it gives you a lot of leverage in building two different kinds of networking for monitoring and data plane communication. Okay, so if you break this down a little further, what does that really mean? Well, let's take basically a network packet broker box and do a compare and contrast. In a network packet broker switch, they typically are proprietary. They are what we call a black box. And those network packet broker switches, for good reasons, have built custom switching into them to do line rate filtering for what you need when you're monitoring the data. Now, to do the line rate filtering in this approach, you have to put a custom box at every ingress point into your network, right off of where the server communication's coming in. And those boxes, because they have custom silicon, typically FPGAs, are more expensive than a standard switching blade, if you will, from, let's say, Dell as a 1RU switch. So there's more expense associated with them. And those typically need to be managed on a box-by-box basis. So then you incur more of an OpEx cost with it. And you can begin to see how the expense of a network packet broker fabric, if you will, using these black boxes become more costly and actually harder to control and manage. Now, our approach, as we've mentioned, is to disaggregate the box, the hardware, from the software and the control points, and how you would steer and manage and access the data. and the steer management and access of the monitoring data is up in the controller, typically, and we use an x86 platform for that because it has better optimized processing and management for it, and you can use Linux as your common build there, and you build something that's a lot more industry standard, if you will. So you have a network operating system down in the data plane that moves the traffic, and it's controlled by the controller that basically tells the data plane where to steer the traffic, and it can be easily steered over to your monitoring tool of choice in an open architecture. And in saying such, we've spent a considerable amount of time with the industry analysts, and especially with Gartner, and they have recognized our vision here in terms of where we believe networking needs to go. Our focus has been primarily right now on the data center because that's actually where you can get a bigger cost benefit moving from a black box strategy to a white box strategy, and to disaggregate it and bring down both your CapEx and your OpEx. So obviously, as you can see from this slide, Gartner has recognized our vision here. They are a little low on our execution, knowing that we are a startup, but we are quickly making inroads into various different enterprise accounts and actually have a considerable following in terms of our product and our success here. Here's a couple customer validation points. I'm not going to read them, but we do have a growing customer base that has actually deployed both the offerings in production, and they've been successful on their end in using our technology. And I'm going to stop here. I'm going to stop for a quick polling question, and then we're going to switch gears, and then Praful is going to get into a little bit more of the products themselves, and then he's actually going to go through a demo of the new offerings we have here. So if you could respond to the polling question here.
Thank you so much, Bill. I think that's great. I think it's really interesting. We've definitely seen this kind of raise to the top of the world as far as what people are looking for, especially with a lot of the things and IT challenges that a lot of our customers feel. What do you think you're seeing? What's the market trend? Are they doing it now, or are they doing it later?
If it's a question for Praful and I, the answer is they're doing it now. I mean, security is top of mind for all IT organizations. And if you look at the latest industry events, basically data privacy is becoming a big concern as well. And so customers are needing to audit how the data is being sent, used, and consumed, as well as continue to monitor for all those security threats that are taking place.
I think with everything that we have with all of the security breaches, I think you're right. This is definitely top of mind. I'm going to close the poll now and share results. We have 17% within 6 months, 25% within 6 months to a year, 42%, which surprises me, has no plans at all, and 17% is more than a year. So thank you, everybody, for participating. We're going to head back to the presentation.
Hello, this is Praful Paidasna. I'm the product manager for Big Monitoring Fabric, and I'd like to thank Bill and Sharon for their introduction and leading into the Big Monitoring Fabric, which I'm going to talk about from now on. I'm going to lead with why Big Monitoring Fabric, and that's the question I asked a customer, and I got the most unusual answer. The answer I got was because it solves not only my problems for today, but also my problems of the future. It said, most people are worried that if their organization succeeds, they will have a lot more work, they will have a lot more problems to manage. But with Big Monitoring Fabric, I don't have that problem. And that's why I love this product. And that sort of aligns with the SDN message of simplicity, of scale out, of open vendor or open Ethernet switching that we are talking about. So here's a brief update with regards to what Big Monitoring Fabric can do. So you have your production network. On the left-hand side, you have a centralized tool farm, and you have a fabric of switches managed by a controller. These fabric of switches operate like a single logical big switch, and hence the name of the company, Big Switch. These will give you about 80% of your use cases. Filtering, load balancing, aggregation, replication, you name it, it'll be done. The additional 20% comes with the Big Mon service nodes. You can take in your existing network packet brokers and connect them as third-party service nodes, or you can buy Big Mon service nodes, which are an x86 industry standard appliances, to give you these additional functions like GTP correlation, deduplication, packet slicing, so on and so forth. Taking on after this is we now not only monitor a single data center, but also remote data centers. So you can leverage the same controller pair to monitor multiple different sites and still send all your feeds, all your monitoring, your security, your visibility traffic to a centralized tool farm. That's what we're talking about, keeping it simple even as you scale, even as you grow. Now, extending this, today we are going to talk about two new components to this Big Monitoring Fabric. One is Analytics Node and the other one is a Big Mon Recorder Node. In fact, both of them have been asked for by our customers. They would come and tell me that, hey, Praful, we're looking at an SDN solution using open Ethernet switching and a service node using an x86 industry standard server. How can you further simplify for us? We'd like something with analytics all integrated with the controller. I would like to have a recorder, again using an x86 and again integrated with the controller. Because finally it's the end-to-end workflow that matters for the customer. And that absolutely made sense. So today we are going to talk about this, and we're going to talk about the unique benefits having an integrated architecture brings into the realm of operationalizing visibility and security deployments within an enterprise. And very soon we are going to talk about how do we move our monitoring and security solutions into the cloud. So that's going to be coming very soon, but I'm not going to talk about it today. But keep in mind that this is right at the horizon in the next webinar. What are the advantages of this architecture? From the controller, given it's a centralized control plane, it provides simplicity. It provides an intent-driven workflow. And it is completely REST API. It is fully programmable and automatable. For customers who love using the controller, you will find workflows that will make it easy. For customers who want to take it and build into their own systems, they will find enough hooks for them to make it happen. And this is always your single pane of glass, irrespective of how many switches you have in the fabric, irrespective of how many service nodes you have in the fabric, irrespective of how many analytics nodes you have in the fabric, and how many recorders you have in the fabric. The switch fabric uses speeds from 1 gig to 100 gig, Broadcom A6, open vendor switching. So we use white box, bright box switches from Dell, HPE, Acton. And using all of this, we give you production grade solution, which customers have deployed, by the way, for now about 4 years. And are continuing to buy. It's not that they bought the first time. So with all of this, you get scale, you get resiliency, and you get a solution which will work, solve your problems for today as well as for tomorrow. The service node is an x86 based appliance. We have two form factors, a 4 by 10 gig in a 1 RU and a 16 by 10 gig in a 2 RU. Now you may have a question that, okay, you're talking about so many services in the service node. How can an x86 server be able to give you this performance? Because clearly to do all of these services, you would need to have line rate performance. And here the cool part about all of this is, for the service node, we are leveraging Intel's DPDK technology, Data Plane Development Kit, that provides you line rate performance. You do not need to invest in expensive box-by-box managed custom hardware. Using industry standard hardware, there are solutions out there right now, like the service node, that help you gain a much better CapEx as well as OpEx advantage. Now let's talk about the two new technologies that we are bringing today. One is the analytics, and the second one will be the recorder. So from analytics perspectives, what do you think are the customer requirements? Given that everybody is moving to cloud-native architectures. Given that the networks are growing, given that the workloads are transforming from physical to virtual to cloud, there is a lot more data that needs to be seen, that needs to be checked, and that needs to be validated. What that means is you need to have a lot more intelligence, because you cannot just keep buying a lot of tools and hope that the tools will figure it out. And finally, you need to have some sort of programmability to enable workflows that help you trigger smart user workflows. And that's what we do with the Analytics Node. So in simplicity, Analytics Node gives you real-time information as well as historical information, and gives you dashboards for centralized traffic visibility, pervasive security. It helps you identify performance anomalies and a lot more. Again, it's used on an industry standard x86 server appliance and gives you the performance. You can have one or multiple. This is a pay-as-you-grow model, which applies to your switches, your service node, your analytics, as well as your recorder. So you can start with one as you see that, okay, now your organization is growing, the data you need to manage is growing. You can buy another one and you can cluster them together, still keeping the same single pane of glass. And that gives you the simplicity as you look towards the future. Now, looking at the packet capture, you have the similar set of requirements. You need to capture flows. How do you scale? Is there a way you can filter traffic intelligently so that you know what you're capturing? Or is there a way you can scale the recorders, sort of building like a logical recorder node, because you still need to have a single pane of glass to query the data, because you don't need to know which recorder node has which flows and go appropriately to the right recorder to get the information. And finally, how do we programmatically enable all of this? Because doing it manually in this day and in this time is really hard and complex, given the high bandwidth that's coming up, given that the network is continuously transforming, given that you have to deal with physical, virtual, cloud workloads. There needs to be a better way for making this management, making the monitoring, making security simpler and more robust. So with the recorder node, again, and I'm going to repeat this, we are making the recorder node on an industry standard server, which is the x86 server. Our first phase of the recorder will have 160 terabytes hard disk storage, and it is logically scalable. And you can see in the diagram, I have multiple recorder nodes, and they look like a single big logical recorder node when it's connected to Big Mon Fabric. So the cool part about all of this is it now builds an integrated fabric. Your network packet broker is integrated with the analytics, is integrated with the recorder. You can think of it at a very high level that the analytics by itself will provide you macro level visibility. So it's very easy for you to identify outliers, performance anomalies, congestion, security related issues. And then you can select that anomaly and then say, okay, let me get the packets from the packet recorder for that, and then find out what really is happening. And that sort of a workflow is an end-to-end workflow for a user, for him to quickly troubleshoot and mitigate the issues that he sees in his environment. So here's an example. So you have a Big Mon controller integrated with the analytics node and integrated with the recorder node. So from the analytics perspective, you look for anomalies, you look to identify performance issues, any interesting events. And then once you find that, you basically place a query to the recorder node, which starts capturing all the future flows. So now you're doing a smart capture. You're not just blindly capturing everything that's there in the network. There are cases where you may need to do that, but there are cases where you can actually be a little bit more smart about it, and so that you are optimizing your storage, you're optimizing your visibility, and you are having a rapid mitigation, because if you have a lot of data to capture, it's hard for you to figure out where something went wrong when something does go wrong. Now, extending the smart capture is smart replay. So we have the same flow. You have anomalies that you look for in the analytics. You query the packet recorder for the packets and flows. And now the packet recorder has two options. He can send you a PCAP file back to analytics, which you can then see and investigate further with regards to the PCAP. Or the packet recorder can now leverage that it is connected to the Big Mon controller's Big Mon Fabric and have the packets automatically be sent to a specialized tool for further analysis. So with this integrated solution, it becomes very easy for you to have adjacencies with smarter tools and more efficient processing of your events. Rather than just sending everything to your specialized expensive tools, you could leverage this sort of an infrastructure and then decide that, hey, I've got this trigger, let me now send this to this smarter tool, which will then be able to give you a quicker turnaround because it has a limited amount of data to go through. With this, I wanted to talk about a very unique use case that we found with our customer, the University of Oklahoma. So the way they are using analytics and recorder with Big Monitor Fabric in the network is as follows. So their use case was they see a phishing attack and they identify it. Once it's identified, now it is important for them to understand that, hey, was there any student in the campus who got actually duped by this phishing attack? Because if he did and he gave out his password, then the security profile of University of Oklahoma is under risk. So what they're doing is once they identify the phishing attack, they're leveraging analytics and packet recorder in combination to get the streams that are applicable for that phishing attack. From those streams, they identify, hey, these were the users who have given their passwords. And so they now know the way to mitigate it is to quickly reset those user ID passwords, let them know, and thus reinforce and resecure the security posture. Now, making this so simple with this automated workflow with analytics, packet recorder, and the Big Mon network packet broker all integrated together is what makes it very easy for them to quickly mitigate once they've identified the issue. And by the way, they're using Bro, the open source tool, to identify whether a phishing attack has happened or not. Let's talk about a few quick use cases before we move on to the demo. So one very simple use case would be, hey, I'm seeing a lot of ICMP traffic come in. So could this be an attack happening? And then you see, okay, is this IP address ICMP coming in on a particular switch? What is the impact? Identify which is the source switch or the IP address that's getting affected. And then you could basically take that traffic and via the packet recorder, send it to a smarter tool for further analysis or to improve your tool to be able to detect this ping of death style attack even more effectively. We can also help with regards to performance-related anomalies. So for example, let's say if you have a lot of incomplete connections, you can identify which clients are having the most incomplete connections. With the clients connecting to which servers when they're experiencing incomplete connections, and when did the problem start happening. With these dashboards, it quickly enables you to dive deeper and focus into the area where you will likely find the issue of or the cause of what happened with regards to all these issues that are being seen. We can also look at security issues, like, for example, if I'm getting traffic from an unknown location, I can go into the packet detail to get further insights with regards to what's happening on the packet. I can identify what are the flows coming in from that location. Is it just an NTP, in which case it's probably okay, or is it something different, in which case you need to worry about what's happening. And it could be an unknown location, it could be a location which is not in compliance, or something that that you may really want to check and say, hey, why am I getting traffic from this particular location? Because I don't think I have any business in that area. So this provides you a very quick and easy way to identify potential issues before they get worse. And finally, unsanctioned website access monitoring, right? So from our dashboards, you can see that, hey, there are some websites which may be looking suspicious. You can also identify which clients on the network are accessing that website. You can go to the packet recorder and get detailed information with regards to what exactly is being communicated with that website, and then quickly understand what is the impact with regards to your security profile for their organization. So with that, I'm going to now take you guys to the demo for the Big Mon Analytics as well as the recorder. And towards the end, we are going to talk about how this integrated approach, and I'll show you how the integrated approach actually makes a huge difference with regards to how quickly you can identify, detect, and mitigate your security or visibility issues that you may have.
Yeah, so while you queue up the demo, Praful, we got one question that came in from an attendee that wants to know the difference between net flow from the network versus the host, and I can answer that. Net flow, first of all, is a network-created accounting data, if you will, generated off of a network interface. It can be generated off the server interface, primarily if you're using a virtualization technology, which has a distributed switch. So certainly from VMware and their VDS technology, it does put processing overhead on the interface. You can do the same thing from the network, and that's where we would recommend it, because you've got a more, you've got a switch with gigabit interfaces in it that really are designed for that kind of packet processing. It's a better place to do it. And the source data and destination are still known, irrespective of where you run the accounting data, because what you're really doing is capturing the 4-tuple header data, which is source and destination primarily. So I would say it's a better way to do it in the network, because it scales better and you've got more focused processing for it than trying to put it on the host.
Big Mon Recorder Node provides broad spectrum network or application view, as well as packet level visibility, leveraging its integration with the Big Mon Recorder Node. Big Mon Analytics primarily is analytics over network metadata, but it also is a collector for and provides insights based on S-flow and NetFlow records. With that, let's start with the S-flow dashboard. Across the top here, you see typical 4-tuple selection for flows. Now, the special feature of this dashboard that we've added is we present you points in the Big Mon network from where the flows were picked up. And additionally, we also give you correlations into your production network and show you what production switch and interface the flows came from. Now, over here, you see a presentation of flows by the internal versus external classifications. And when you hover over, these different colors that you see are called out on the map. So you can see, for example, how external traffic is changing over the course of the evening here. Down here, we have a presentation of the source and dest IP geolocated to points on the globe. And here as well, we have interactivity. For example, we can select for all flows that are destined to Africa. This gives us a lat-lon filter, that is a filter based on latitudes and longitudes. And the entire dashboard is filtered to just flows going towards Africa. You can see from here that the destination IP address had label NTT America and was NTP recognized basically by the L4 port label. So probably nothing of concern.
This should give you an idea of how this feature can be used by organizations to ensure there is no traffic going to non-compliant, unauthorized, or unknown locations. In addition, we have set up labels by IP CIDR blocks, so we are able to do searches for all flows. For example, coming from QA and coming over VPN. We run that simple query and we get the filtered flows between the QA and the users coming in over VPN. These would be the IP addresses involved, and then when we come down here to the bottom table, we see the source description and the desk description with OpenVPN and QA labeling as you would expect. Let's talk about pod monitoring, also known as hop-by-hop monitoring. Realize here that this presentation by filter interfaces and points in the production network give us an ability to do hop-by-hop debugging. For example, now we are seeing flows on 4 points of the network. If these flows were expected to be seen on 5 points and there was not a fifth slice, this gives us an idea into what part of the production network we need to investigate further. Next, we have this NetFlow dashboard. Here again, we have done a similar presentation to show you at what point in the Big Mon fabric the NetFlow record was picked up on and the associated production switch and interfaces as in the SFlow dashboard. Down here, you see a breakdown by ASN labels. We notice again we see internal IP block labels like QA, SVC for a services organization, as well as external ASN labels like Google, GitHub, etc. So from this, at a glance, we can tell how much traffic is going between a service organization. You can filter on that, and Cloudflare, for example. That was a quick filter, and you can see that that traffic was happening just once around 8 p.m. And a quick tip here, actions done on this dashboard can be used to automatically populate the query to fetch packet data from the Big Mon Recorder Node. Next, I want us to take a look at latency tracking. We admit control packets into analytics, and we present that here in the tracked connection dashboard. We bring in SYN/SYNAC packets, and the time delta between them allows us to determine connection setup latency that is presented in the line graph here for all flows that are coming in. So these peaks here correspond to the identified flows on the right table. We can see here, for example, this flow corresponds to the first row, and at a glance you can tell that it is a QA flow going to 10, 9, 16, 60. In this way, you can work down the list of flows seeing high latency. Now, this is the presentation of all the flows in aggregate. You may do very specific debugging by selecting an exact flow of interest and selecting as many of the 5 tuple as needed and characterized, for example, flows between 10.8.23.75 and 10.8.6.90. You can see the flow table now pertains to just that one flow, and you can see how latency has changed through time. The other scenario that we hear frequently requested from an NPM perspective is congestion characterization of the network. Now we can tell from viewing on a filter interface, for example, here we see DT-Leaf1B has a lot of traffic coming in. So we can select that filter interface and see just the flows on that filter interface. And we can tell here that a lot of traffic from 38.50 was going out to the purple section 8.8.8.8, which everybody knows is Google. In addition to insights on dashboards, Analytics is also able to send out alerts. Let's take a look at a few of them. This, for example, is an alert set on bandwidth utilization on the filter port. When actual use exceeds the set threshold, we send out this helpful email to tell you what were the flows that contributed to that threshold violation. Another alert that can also be sent out is when the mix of traffic being monitored changes. For example, when you have a lot of external traffic making up your total, an alert email like this could go out telling you what the top source IPs were, what the top destination IPs were, and also have this graphical depiction of the flows between the source and the dest IPs. Furthermore, it also tells you what types of flows they were. Finally, we leverage ops to create a report like this which can go out every 24 hours. This tells you about all the new hosts that have joined your network in the past 24 hours. Now let's look at Big Mon Recorder Node and how it is launched from Big Mon Analytics. So starting with a search on metadata for the host name, let's say Robert, we can find IP addresses for Robert. Let's select this. With that source IP selected, we can now step into the packet recorder. And we can see the source IP carried over. We can do a get summary and we can see those 24 megabytes of data. Get detail runs NDPI against the 24 megabytes and it gives us a breakdown, notwithstanding encryption, what different categories of traffic were in that 24 megabytes. Finally, let's do get packets now. What happens now is there's a REST API that goes to the controller. Now behind the controller, there could be multiple packet recorders. The controller gives us a coalesced URL for all the packets coming from different packet recorders. When you click on that coalesced URL, you can have the packets downloaded to your laptop and gets opened up in Wireshark. And here we are now at the ground truth of packets. Notice here, it is also possible to have these packets sent out to a delivery interface. This is possible due to the integration with the Big Mon fabric. So you could have a very expensive tool, for example, connected to one of these delivery ports, and you can have packets of interest sent in a very agile and flexible way towards that one tool. In this way, leveraging that expensive tool for the exact packets you wish to investigate. Furthermore, you can do flow analysis. For example, you can do HTTP flow analysis, which shows the separation of the request and response packets. We open up one of them and we can see the breakdown by the HTTP response codes. On the response, we can see what HTTP method was invoked. Likewise, you can do an HTTP request flow analysis. This gives us visibility into the HTTP hosts and its URLs. That's all I have for this demo. Thank you.
Great, thank you very much, Praful. I think that was terrific. We do have another poll that we're going to launch, we just want to know a little bit more about what you believe. So if you could share that with us, we'd really appreciate it. You'll find the poll should pop up on your screen. And we really want to know, do you believe analytic and packet recording tools will be helpful in researching and solving your visibility security related questions? Let us know. And if you actually have any thoughts you want to share or comments, please put that in the questions tab, which is our chat for you, and we'll be glad to share it.
The key point is truly end-to-end visibility, as we've been talking about earlier, because you could have analytics as well as recorder get overwhelmed with the amount of data that gets thrown at them. Our ability to have smartly requisite data sent to the requisite tools will help aid in immensely various organizations in quickly mitigating their performance or security issues.
Yeah, and along those lines, Praful, I believe it's the 1% that you have to look at from a security and compliance perspective, and how do you filter for that 1%? I think in the future, and this goes to the architect that we have developed, which is both for today's environment and in tomorrow's, to segue into what Praful started with, is machine intelligence. And you're going to basically look at normalized traffic, and then the machine will look at abnormal traffic, and we'll be able to take action on the abnormal traffic behaviors, which you get from the monitoring fabric and the analytics nodes, and make either alerts and/or remediation and/or quarantine actions that give you better protection. Because there's no way that a security ops person can react instantaneously to some sort of malicious activity that's going on within the environment. It has to be done through machine control and machine learning.
So as you guys can see, we have 82% said yes, 9% said I think so, but I need more information, and 9% are just not sure yet. So let me close the poll, and I know we're going to run into the questions next. Reminder, all you need to do is go to your question pod on the dashboard and ask questions. We have quite a few questions that have come up, so let me go through them. We have a question from Poland, actually. Is it scalable with VMware NSX? And if so, how does it work?
Yeah, I'll be happy to take that. The answer is absolutely yes, and that is actually one of the whole reasons for putting in a out-of-band monitoring fabric, if you will. Scalability is to basically offload a lot of it from the host node itself, and we actually have control capabilities of where you can filter and monitor only at a VM level using SPAN or ER SPAN, and/or you could basically use the NetFlow accounting that they offer, and we can analyze that as well with IPFix. And you actually saw Praful in his demo showed some of the NetFlow accounting capabilities we have using that accounting data and the analytics that we do there. And also you could do full packet capture and replication, pushing it through the out-of-band fabric. So the answer is yes, we absolutely can scale, and there's various different ways to go do it with either NetFlow or ER SPAN or packet capture and those type of things. And actually VMware is enhancing it with a new interface that we're going to be integrating with, which is called NetX, which actually basically uses the NSX controller themselves for how you set up and filter the traffic. And so we'll have a controller kind of programming there to provide that interface as well.
Great. Next question. How are you identifying who is accessing a website? This person understands identifying which workstation, but how are you able to pinpoint the user?
Also have integrations with OpenVPN as well as Windows AD user database, and we use that integration to identify who is the user who's logged in to the network.
We have a good question about whether or not there are any hands-on labs that we provide, so someone can check to see how it all works. And yes, you're ahead of the script. We'll pay you later. But we offer Big Switch Labs, which is free and gives you a chance to really get real-time access to all of our products. And we'll show you a little bit later as to how you can access that. It's also, if you're interested, there's a handout in your on the dashboard that gives you all the information you need to know about Big Switch Labs. I have a deep investment in several security monitoring and enforcement tools. Can I continue to use these, or does the Big Mon fabric, inclusive of the analytics and recorder node, replace them?
We basically are all for protecting your investment. We know that customers have a deep relationship, if you will, with their security tools. They've had them for years, and they, in fact, not only is it, knowing the product and having the people trained on it, they have them integrated from what I would call a runbook perspective, meaning that they have a set of procedures and guidelines written around those tools. So you absolutely do not want to take those out of there. Our Big Mon Fabric, if you will, helps those tools scale more easily. The Fabric approach basically allows them to basically connect in a more clustered fashion, because we can actually load, distribute, and load balance the traffic to them, so there's benefit there. And those devices are typically your standard node host appliances, if you will, IP addresses and 10 gig, 40 gig interfaces. They're fully compatible with what we're doing here from a Big Mon Fabric perspective. So we absolutely believe in protecting customers' investment there.
We have a question for you. Can I purchase just the Recorder and Analytics Node without having to invest in a Big Mon Fabric out-of-band network?
So if you look at it in a way, the Recorder Node is also a collector for S-flow and net flow records. So that means from your production network, or even Big Monitoring network for that matter, it can collect those records. That said, if you really look at the value prop here, it's simplicity with end-to-end workflows. And for that to happen, we'd recommend you to have at least one switch and a Big Mon controller, and then have this integrated solution, and then you will see the benefit that you have with regards to how the analytics works with the control packet information that the switch sends to it, how the packet recorder works with the additional filtering that gets triggered by the analytics via the controller with regards to what data has been stored in the packet recorder. This simplified approach and integration with the ability for you to customize exactly how you want to use your infrastructure so that you can troubleshoot your environment is what is making this solution a tremendous value prop for our customers.
Great. That's all the questions we have time for today. And I know that if you have questions, I know there are quite a few, we will actually do them offline so that you can get the answers that you need. So as you can see, we definitely have the best way to get it started. So what we have created is our Big Switch Labs. So it's labs.bigswitch.com, where you can actually take a test drive for Big Switch and see how it works, what you need, how you can support it, and then if you have any questions, feel free to reach out to us. All you need to do that is info@bigswitch.com, and we're happy to share or get you the information you need. So
great insights, Bill and Praful. Thank you so much for all the great information, and thank you to our audience for such great questions. We're running short on time, so let's wrap up. We make it easy for you to get started with our Big Switch solutions. There's several resources you can download, or you can watch a video that will give you a tour of our products. In your handouts, you'll find live links that you can access any of the resources listed, as well as resources here from our panel today. With Big Switch Labs, you can experience Big Switch bare metal SDN solutions firsthand from the comfort of your PC. We believe that there's no better way to learn about a product or technology than to take it for a test drive. For free online real-time access to our SDN Fabric products, please visit labs.bigswitch.com. Please join us for our next webinars. The first up is a customer success webinar with University of Oklahoma entitled Building a Cloud-Native Network Defense and Rapid Remediation at Scale. That will be on Thursday, May 24th at 10 a.m. Pacific. And on Wednesday, May 31st, join us for Container Networking, Mesosphere, and Big Switch. You can watch your email for registration details or check our website webinar catalog at www.bigswitch.com/webinars. That concludes our webinar for today. Thanks for joining us. Hope you have a great rest of your day.